question, half-life of radium is given to you and you have to calculate the decay constant of radium. So half-life is given to you and half-life is represented as capital T, 1620 years, and lambda is the decay constant. So we know that T is equal to log base E2 divided by lambda. So from here, lambda will be equal to log base E2 divided by capital T. Now put the value. So T is, so if you put all the values in this formula, you will get the decay constant as 4.3 into 10 to the power minus 4 per year. So this is about the question. Now what is the half-life? Half-life is the time interval in which a substance, the initial mass or the number of atom in a substance will reduce to its half. That time interval is known as the half-life. इस क्वेश्चन में भी आपको हाफ लाइफ दी है और पूछा है how many years, after how many years 1 kilogram of sample of radium will reduce to 1 gram. आपसे पूछा है कि 1 किलोग्राम सैंपल रेडियम का कितने टाइम के बाद will reduce to 1 gram. Let's solve this question. So in this question, half-life is 1600 years. N0 is the initial value of the substance, which is 1 kilogram. And the final value of the substance is 1 gram. So we can write N in terms of N0 as point, because N is the 0.001 time of N0. Now we have the exponential decay equation, which is N is equal to N0 e to the power minus lambda T. This time interval we have to find out. We know N, we know N0. N is the reduced value of the substance, N0 is the final value, initial value of the substance, and lambda is the decay constant. So we don't know decay constant lambda. So this lambda we can find out from the half-life value T, because lambda is equal to 0.6931 divided by 1600. So we get lambda 0.00043 per year. Now put all the value in this equation. This is the exponential decay equation. Now put all the values in this equation and find out the value of T. So we have put it all the values. So here this e to the power minus. So take a reciprocal of the whole equation. So you will get here 1 upon 0.001. You can write this value as 10 to the power 3. And this will be equal to e to the power 0.00432. Now take log on both sides. You will get log base E and this value. Then convert log base E by multiplying 2.303 into log base 10. So I have done all the calculation and I have got the value of T. This many years will take to reduce radium from 1 kilogram to 1 gram. So in this question, we need two concepts. So first, how we will calculate the value of decay constant, and then we should know the exponential decay equation. Okay, now let's move towards the next question. In this question, a radioactive nuclide decays to form a stable nuclei. Its half-life is given to you, which is 3 minutes. Then it is asked in the question that what fraction of its 1 gram will remain radioactive after 9 minutes. So let's solve this question. Write all the given information and then we will proceed. So T half-life is given to you 3 minutes. So half-life means the substance, the number of atom or the substance will reduce to half of its value. Means if initially the value is 1 gram, then after 3 minutes, it will reduce to 1 gram by 2. Okay, so we will find out how many half-life this substance will pass through in 9 minutes. So how many half-life means n? N will be 9 divided by 3. Means 3 half-life the substance will pass through in 9 minutes. Means in first 3 minutes it will reduce to half of its initial value. Now in another 3 minutes it will reduce to 1 gram divided by 4, half of this value, and then another half minute it will reduce to 1 by half of this value. So this will be equal to 1 gram by 8, and you can directly write it as n is equal to n naught into 1 by 2 to the power n. N is the number of half-lives. So this will be equal to n naught is 1 gram. So this will be 1 by 2 to the power 3, which is 1 gram divided by 8. I think this question will be clear to you. Now we'll do the next question. So this question is very similar to previous question. Half-life is given to you, initial mass is given to you, which is 1 kilogram, and then asked what fraction will be remaining after 4,800 years. So you need to do same thing as we have did in the last question. Find the number of half-lives it will pass through in this time interval in 4,800 years, and then do calculation. So these informations are given in the question. The half-life is given, the total time interval is given to you 4,800 years. The initial value of the radium is given to you 1 kilogram. Now find out the number of half-life it will pass through in these much years. So this will be 4,800 divided by 1,600. So n is equal to 3. So n will be the fraction, remaining fraction will be, the remaining radium will be n is equal to n naught into 1 by 2 to the power 3. This will be equal to 1 into 1 by 2 to the power 3. So this will be 1 by 8. So here 1 kilogram by 8. Now in the question you have to calculate the remaining fraction. So fraction will be equal to n minus n naught divided by n naught. The fraction will be equal to n naught minus n divided by n naught. This will be, so we can write this as n naught by 8. This will become n naught minus n naught by 8 divided by n naught. So this will be equal to 8 minus n naught is 7 by 8. 7 by 8. So 7 by 8 fraction will be remaining after 4,800 years. So this is the answer of this question. If you want more videos or more solutions like this, for that you just need to do one thing. Press the thumb icon, subscribe and hit the bell icon, and please share with your friends. Thank you.